Fascinating. Well, what about energy? We're still going to need it in the future, right? Petrol and coal, well, what will we do when they run out? What if we could find a new, renewable, abundant and clean source of energy?
The world is on a quest to find a replacement for oil, particularly as a transport fuel.
Because what we've got is running out.
Surrounding us is the world's most efficient storable fuel factory. It's called photosynthesis.
For billions of years, plants have been harvesting sunlight for their own energy.
Just imagine leaves full of tiny photovoltaic cells with chemical nanofactories using the sun to power life.
This is the heart of photosynthesis, and we're learning to mimic it.
A leaf first creates electricity from sunlight to split water into oxygen and hydrogen.
Plants, being expert chemists, combine hydrogen with carbon dioxide to make a storable fuel.
We're separating out the three steps: light into volts, water into hydrogen, and hydrogen into transportable fuel.
Our research is making progress with an artificial enzyme which captures light and is starting to split water.
Look about you. The sun is abundant and photosynthesis is everywhere.
And in recreating it, we'll be building the world's ultimate green power plant.
Please welcome Dr. Warwick Hillier and Professor Elmars Kraus. Hi, Elmars.
How do you do?
Hi, Warwick. Now, can I work out if I've got this right? The sun is used by plants like spinach to act as to sort of help split water into hydrogen and oxygen, and it uses the hydrogen as fuel. Is that right?
Yeah, that's right.
So the way we can possibly replicate that, solar panel,
Yes.
creating electricity, which isn't new, going into water, and what's happening in the water?
Well, this is just seawater, and what it's got is 2 platinum electrodes in there.
Yeah, right.
The voltage from the panel, and you'll notice there's bubbles coming from both sides.
Yeah, on this side.
One side there's more bubbles.
And what's that?
That's the hydrogen.
That's hydrogen, that's fuel.
Yep.
And you can either use that straight away as fuel, or you can store it as a carbohydrate and use it later. The other electrode?
Yeah.
The other electrode
makes oxygen.
Right.
Yeah.
Now, the problem is the platinum, there's not much of it and it's hard
very, very expensive. So nature uses manganese as a different metal in the plant there that does the same reaction. So we're trying to use manganese instead of that very expensive platinum that can then be scaled across the whole world.
Say that was a litre, the equivalent of how much, say, petrol could you get out of it?
Well, half a litre of petrol. The energy content of half a litre of petrol.
That's freaking amazing, isn't it?
We'll take it.
Come over and sit down. It is amazing. And I think the panel, well, if they don't think it's amazing, they should. They should. Mark, do you think it's amazing?
I absolutely do. Elmar's work, this work blows me away. You're actually trying to reverse engineer photosynthesis. What are the steps that you need to make work to get this process done? If you're close, what needs to be done?
Well, we're working on building that catalyst with the manganese, the metal manganese. So what we're doing is building proteins to bind that metal, and they self-assemble. They're not using organic solvents, they're using water.
So I'd have to say that I think the concept of artificial photosynthesis would have to be as exciting as any other futuristic concept there is going around. The implications of it are absolutely massive. And in terms of hydrogen as a fuel, looking at specifically that aspect of it, how is that going to compare, though, economically and practically with second-generation ethanol, for example, development out of, waste straws and crop residues and so on?
I think we're in a position where we have to try everything. And I think you can try to make ethanol out of, but you certainly can't use the amount of land that it would require to fuel all the cars.
Absolutely.
We need to approach all these technologies with vigour and just really find what it is that works, because we're in that situation. We really are.
You are darn tootin' right. That is so right, Sally.
Warwick, some algae have over 50% oil content and they're really hardy. Can you see a future where you can use the life of the algae to photosynthesize and then at the end pull out a biodiesel?
Yes, there are some algae that produce hydrogen as well. So you could use them to produce hydrogen, and then you could use them to produce
That's fantastic.
biodiesel fuel.
Summing up, Mark.
Well, this has, I think, potentially could really change the world. If we can actually get to a hydrogen or a proton economy, they're calling it, where people can just make their own hydrogen, because this, again, can be very decentralized. You can make it at home, put it in the car, run the stove and everything like this. This would change the way we use energy.
Yeah, and photosynthesis is the very beginning of the whole cycle of life. So, I mean, what you're playing with here is the core of our whole existence on Earth, not to mention getting about $20 million out of Bill Gates for moving. Do you guys want a business partner by any chance?
You know, it's quite inspiring to have people on, not just you, but all our guests tonight, who aren't saying it's too hard, look at the obstacles, but are just saying, damn it, we're going to do it. So thank you very much for coming in, and good luck. Please thank Dr. Warwick Hillier, Professor at Almost Strong. Thank you so much. Man, I cannot believe that fuel. Those guys, I just think they're extraordinary. Before we go, I want from each of you one prediction for something that we'll have achieved by 2020.
Well, I think we will solve. I'm absolutely confident that we will solve the feeding of the world off the reduced hectareage.
Sally?
Yeah, well, mine keys in with that too. I mean, I am sure that we will find a biofuel for mass transport. And I mean, my personal little bet is on algae, because it doesn't require land. It doesn't require land. It can grow in water and it can grow intensively. And, you know, I think that that will be solved. I'm not too panic-struck about my transport.
And the other thing with that, of course, is that it's going to allow us to... I don't think we're going to do anything about climate change. We've got to adapt to it, and what you're saying will help us do that.
Yeah.
Your prediction?
Well, the big thing I see coming is synthetic biology, and we've seen a sort of...
Synthetic biology?
Synthetic biology. What they've done is they've taken, like, bacteria, and they took all the genes that are in bacteria and they started knocking them out until they found the minimum set of genes. It's sort of like the basic set of instructions that can make something for life. They said, okay, we know that. Now what we're going to do is we're going to start just from genes and start adding them until we get something that's alive. And so when this happens, biology leaves the realm of pure science like physics, and it becomes a branch of engineering, and that's a game changer.
Well, you know what my final thought is, and that there's a kind of an irony in that all the human ingenuity that has allowed us to get out of the caves and given us such improved quality of life has also created all these problems. But we see people every week on this program who are displaying such a marvellous quality of human ingenuity that I'm kind of real confident that somehow they will continue. You know, what got us into this mess, our brains, will get us out of it. That's what I reckon anyway. Hey, thanks for joining us. Thanks to our guests and panel. Applause.
Thank you, Graham.
And let's all meet back here in October 2020 and compare notes on how accurate we were. The final word goes to a man who was a pioneer in the uses of magnetism and solar energy, Charles F. Kettering. He said, "My interest is in the future because I'm going to spend the rest of my life there." Good night. We know that last week the panel picked Paul Blazovic and his panel form. But what did you pick as the people's choice? There was the Will Save power line detector, the stubby cooler and the panel form. And you picked the panel form.
G'day everyone, Adam Hills here, getting ready